Today I will solve MCQs of homogeneity, that is as physics topic. So I am solving my own topical, and I will discuss homogeneity problems. You already know that the homogeneity means that if an equation has same SI based units on both sides, then this is homogeneous, and every correct equation must be homogeneous. So let's discuss this question. Which formula could be correct for the speed of ocean waves in terms of density of seawater, acceleration of free fall, h is depth, and this lambda is wavelength. So we have to identify the formula that is applicable for speed, and all quantities are given. This rho is density, and g is acceleration of free fall, h is depth, and this is wavelength. So let's check this first option. On the left hand side, the unit is ms minus 1, that is speed. So on the right hand side, if I simplify this is gravitational acceleration, and the unit of gravitational acceleration is meter per second square times the wavelength. The unit of wavelength is SI base unit of wavelength is meter. Okay, so that is meter square s minus 2 whole power 1 by 2, and that is m2 times 1 by 2 times s minus 2 times 1 by 2. So m s minus 1. So on both sides, the units are same. So this equation is homogeneous, and this can be used for speed. And there is no need to check other options. And if you want to check the second one, this g is gravitational acceleration, that is meter per second square over this is meter. So if you simplify this is not the unit of speed. So on the right hand side, this is not this expression has not the unit of speed. So this is not the correct formula of speed. And even if you will simplify these two and find the SI base units on the right hand side of these two equations, then you will get that this is not equivalent to meter per second. So A is correct option. The maximum theoretical power of wind turbine is given by this equation. P is K rho A V power N, where rho is density, A is area, and V is speed. And this K has no unit. What is the value of it? This is again very important type of Cambridge question, that if you are given a formula and on the basis of homogeneity, you have to find some unknown, some power of any variable. You can do this on the basis of homogeneity. So what is the basic idea behind? You have to put, what will you do? You will put SI base units on the both sides, and you know that power is defined as work done per unit time. So work done is F into D divided by time. So first of all, we should get SI base unit of power, that is force is MA. So kg meter per second square. This is A and this is M, and times this D is meter divided by this is second. So we will get kg m square. This one will be added, and minus 2, and this will go up, that will make it minus 3. This is SI base unit of power. Okay, so what will we do? We will put SI base units on the both sides, and then we will compare SI base units, compare the powers of same variable to get unknown. Okay, so put SI base unit of power, that is kg m square s minus 3 times, forget about this k because this has no unit. And density is, you know that density is mass per unit volume. So kg m minus 3, this is unit of density, mass per unit volume, times SI base unit of area is meter square, and speed is meter per second whole power n. Okay, so now what we have to do, we have to simplify uh, on both sides. So on the left hand side we have this expression, and on the right hand side this is kg. And let's simplify these two, m power minus 3 plus 2, that is minus 1, time m power n. This inside power is 1, this n will be multiplied with this 1, so that is n. And what will be the power of s? That is minus n. Okay, so kg, what can we do now? We can simplify this m, that is minus 1 plus n, and s power minus n. kg m square s minus 3. If these two things are equal, then the powers of same variable should be same. Okay, so let's compare power of m. On the left hand side you have power of m is 2. On the right hand side power of m is minus 1 plus n. So from this you can get n, that will be 3. Or you can compare power of s, and on the left hand side s has minus 3 power, and on the right hand side this is minus n. So again you will get same answer. So this is the basic idea, that you have to put SI base units of all given quantities, and at the end you have to compare powers of same variables, and if two expressions are equal, then the powers of same variables on the both inside should be equal. And you know this already. For example, if x power a equal to x square, then a is equal to 2. Okay, again this is very same type of question is this: the drag coefficient CD is a number with no unit. So this CD has no unit. It is used to compare the drag on a different cars at different speeds. It is given by this equation: drag coefficient is 2f by rho v power n times a. So f is force, this rho is density, a is the cross-sectional area, and v is speed. What we have to find? We have to find a value of n. So what will you do? Again, if you will face this question in the exam, the basic idea will remain same. You have to put SI base units of all given quantities, and then you have to compare powers. Okay, so you should try it by yourself, but you can stop this video and you can solve it first. So CD, let's rearrange this equation to make it more comfortable. That is CD rho v power n times a 2 times f. You know that these have no contribution in homogeneity, these constants CD and 2. So we can skip these two, that is rho v power n times a equal to f. Okay, so now what you have to do, you have to put SI base units, and you know that what is unit of SI base unit of rho? You know, rho is density, and density is mass per unit volume. So that is kg, this is mass, and volume is meter minus 3. This is mass per unit volume, so I have taken this m in the numerator, times this is speed, that is you should first clearly identify the variables quantities. So v is speed, that is meter per second whole power n, times this area is meter square, and force is m times a. You know that force is mass times acceleration, that is kg meter per second square. Again, what will you do now? You have to simplify the expression on the left hand side, and that is kg is single in this whole expression, and m minus 3, and this m power 1 times n, that becomes n s power minus n times m square, that is kg m s minus 2. Okay, so that is kg m minus 3 plus 2, this is minus 1 plus n, so minus 1 plus n times s power minus n, so that is kg m s minus 2. Now you have simplified the expression, and you have to find the variable n, that is constant. So you can compare this from power of s. On the left hand side, the power of s is minus n, and on the right hand side, this is minus 2, so n is equal to 2. Or you can compare this powers of m, that is minus 1 plus n, and on the left hand side, this is 1. So again, you will get same answer. So it's up to you. So which quantity, which variable you want to compare on both sides. So n is 2. So B is the right answer for question 3. Okay, so question 4. The speed v of liquid leaving a tube depends on the change in pressure delta P and density. This is change in pressure, rho is density, and the speed v is given by this expression where k is constant, that has no unit. Okay, so what we have to do, again we have to use the same recipe, that v is meter per second, and you can skip this k because it has no unit and no contribution in the homogeneity, and pressure and change in pressure will have same unit. Okay, so change of some quantity will have same unit as that quantity. So change of pressure will have same unit as pressure, change of velocity will have same unit of velocity, change of force will have same unit of force. So change of pressure and pressure, you know that is force over area. So force is kg meter per second square over area is meter square. So first simplify this, kg m1 minus 2, that is minus 1 s minus 2. So put over here, that is kg m minus 1 s minus 2 divided by this rho is mass, kg mass per unit volume, that is kg over meter cube whole power n. Okay, so don't worry about this bigger expression. You have to use the same recipe. First, you can simplify on this right hand side. That will be m minus 1 plus 3, that is 2 s power minus 2 whole power n. Okay, so ms minus 1, m power 2n, s power minus 2n, so m s minus 1. So now you have to compare powers of some variable, same, so you can compare powers of m. On the left hand side, you have power is 1, so 1 is equal to the power on the right hand side, so n is 1 by 2. And you can check that if you want to find the power from if you want to this is minus 2n, so minus 2n is equal to minus 1, so you can even get from s power from the power of s, so n is 1 by 2. Okay, so fourth answer is A. So now let's solve this question 5. The speed v of waves on the stretched wire is given by this equation. V is T power P mu power Q, where T is tension and mu is mass per unit length of wire. What are values of P and Q? Now, in a single equation, we have two unknowns, but the procedure is same. We have to put units of given quantities. You know that T is tension and tension is force. So unit of tension will be kg meter per second square, and unit of mu is mass per unit length. So kg per meter. So just put units of these quantities. On the left hand side, you have meter per second, and on the right hand side, kg ms minus 2 times power p, and mu is kg per meter power q. Okay, so just simplify this: kg power p m power p s power minus 2p kg q m minus q. Okay, so now simplify them: kg p plus q powers will add up, and m p minus q and s power minus 2p, and on the left hand side you have ms minus 1. First, the good idea is you can compare power of s to get value of p, that is minus 1 equal to 2p minus 2p, so p is half. Okay, now you can compare even power of kg or power of mass. So kg, on the left hand side there is no kg, so you can put kg power 0. Anything power 0 is 1. So on the left hand side power is 0, and on the right hand side you have p plus q. So we have already obtained value of p, so q will be, this p will go there, that is minus p, and q is minus 1 by 2. So q is minus 1 by 2 and p is 1 by 2. So C is correct option for this. Okay, so now let's solve this last question of this exercise, this subtopic. A cylindrical tube rolling down a slope of inclination theta moves a distance L. This L is distance and T is time. The equation relating these quantities is given by L3 plus A square over P equal to Q T square sine theta. And you should know that sine theta has no unit. Sine theta, this is constant with no unit. This is dimensionless quantity, and A is internal radius, so unit of A is meter. P and Q are constant. So first simplify this equation. Let's say this is 3L plus L A square over P equal to Q T square sine theta. What I have to do, as this equation has more than one terms, on the left hand side you have two terms, and this term has unit of meter. So according to homogeneity principle, if an equation has more than one term, each term should have same units. So this term should also have SI base unit of meter, and this term should also have SI base unit of meter. So L A square over P equal to meter, and you know that L is meter, A is internal radius, diameter, so that is also meter square over P equal to M. So PM equal to M cube. Okay, so this M will go there, that is M cube divided by M, so this is M square. Value of P is, SI base unit of P is M square. And now let's find this unit of Q. Q T square sine theta is no unit, and this whole term should also have unit of meter. So Q T square is second square, so that is meter. So if I make this Q subject, that will be meter per second square. This will go there, and in the denominator it will be second square, and will go up. That will make it meter per second square. So Q is meter per second square, and P is meter square. So B is right option for this question.